Hi, today we're going to be working on 9.1. It's Introduction to Relations and Functions. I'm going to jump to, I would like you guys to read the notes, but let me first start talking to you guys about a relation. A relation is any set of ordered pairs. I would like to show you, whoops, it didn't go, I think I put it away somewhere, but a relation is just an input and an output. It's like if you put information into a computer, something else will come out of it. Your X value relates to the input, your Y value relates to the output. If you have an ordered pair, your ordered pair looks like this. You have an X value and you have a Y value. When you have an ordered pair, the X value represents the domain. The Y value represents the range. So sometimes you're given tables, sometimes you're given graphs, sometimes you're given equations, and you're going to have to figure out what the domain and the ranges are. So that is just a little bit of something that might help you. If I ask you guys, like on example 1, to write a relation as a set of ordered pairs, a relation is used as the letter R. So the relation is equal to, and then these are not parentheses or brackets, they're just like little bat wings, I call them. I think they're cute, like Batman symbol. So this is your first point, this is your second point, this is your third point, and this is your fourth point. So the way I'm going to write it in here is -4, 0, comma, 0, -2, comma, 3, 1, comma, and 5, 1. So you have 4 points and start my timer. And so you have 4 points and that is a relation. There is something else that we have to talk about. It's if they're functions or not. And this is the best way I can explain it. Sure, I want you to read this definition of a function, but I'm going to make it easier for you. Basically, if something is a function, the X values cannot repeat. Cannot repeat. I don't care if the Y values repeat, but the X values can never repeat. There has to be the first component of the ordered pairs. There's exactly one value of the second component. Basically, all of that says is if you have an X value, the X value in the relation cannot repeat. If it does, it is not a function. All right, so let's do some problems. All right, they give you a bunch of, they give you a relation with 3 points for letter A. I don't care about the Y value, does not even help me trying to figure out if it's a function or not. I'm only looking at the X value. Remember, the X value is the first point or the first component to that point. So I have a 0, I have a -1, and I have a -1. If you notice, my -1s repeat. So this is not a function. And it's not a function because the -1, the value X, which is -1, repeats. Now on the second problem, I have a relation with 3 points. My first X value is 5, my second X value is 6, and my third X value is 7. They're all different, so that is perfect. This is a function. Now, if you notice, I have a bunch of 4s for my ranges. I don't care. Don't even worry about it. The only thing that cannot repeat is your X value. Alrighty? So now I would like you guys to read through this. It's basically letting you know that relations can be represented in many different ways. The major one that I do want to talk about is in the equation y equals 2x, the value of y depends on the value of x, which basically means you're putting in some value for x, 0, 1, 7. You're going to make yourself a table, and then you're going to find out what y is. So X is considered the independent variable, Y is considered the dependent variable. Okay? Read through it one more time. I'm going to try to make it easier for you. All right. Now, remember the domain are your X values. The range are your Y values. And then we're going to talk about interval notation in just a second. So if you are given a table like this, we have our X values and we have our Y values. So if it makes it easier for you, just put X here and put Y here. That way you can visually see it. So the number of concert tickets, depending on how much you actually buy of these concert tickets, the cost is going to go up if you buy more tickets. So the independent variable is your number of concert tickets. The more you buy, the more you have to spend. So if I buy 0 tickets, if I buy 1 ticket, 2 tickets, 3 tickets, or 4 tickets, these are your domains. Your ranges are 0. If you buy none, it costs you nothing. If you buy 1, it's $35, then $70, then $105, and then $140. So the domain are all of the X values. The range is all of the Y values. No stress whatsoever. If I were to ask you if this was a function or not, you would say yes, because I have a 0, 1, 2, 3, and 4. That's letting you know that the X value does not repeat, so it is a function. Now, sometimes they're going to give you guys pictures, and in these pictures, they're going to ask you this not yet. I'm jumping ahead of myself. This one here actually wants you to tell me what the domain and the range is. Remember, the domain only represents the x-axis, the x values. So if I were to draw this upside down V, I would go forever in the negative x direction, and then I would go forever in the positive x direction. Well, the way this graph is going, this is negative x axis, and this is positive x axis. So this goes on for infinity. So my domain on this problem would be negative infinity to positive infinity. Those look like sideways 8s. They're not 8. It's just infinity sign. It just means that there's going to be every type of x value that would be part of this graph solution. Now the range, though, is a little something different. The range deals with the y-axis. This is a positive infinity. This is a negative infinity, because y-axis, if you go up, it's positive infinity. If you go down, it's negative infinity. But the way this graph looks is it starts at 4. So I know that it starts at 4, and this is my interval notation like you learned in Algebra 2. Interval notation means if it's a bracket, it means it's part of the solution. Okay? The reason why these are parentheses is because there's so many answers that could go in there. Negative infinity just means it goes on forever. When you have a bracket, it means it stops there. Okay, so now as you notice, I start with 4 as my y value. This one here, my y value is like 3. This one here, my y value is 0. When I start going this way, my y value becomes negative. So this goes on forever to negative infinity. And I put a parenthesis there because remember, it doesn't stop at negative infinity, because infinity just means it keeps on going. All right, now let's do the next one. This is a piecewise function, and this is how you guys, they want to know what the range and domain of each of these are. So the domain of this one is going to be, remember, I'm only looking at the x-axis. So I'm only looking at this graph right here. If you notice, there's an open circle. That open circle at 2 lets me know that 2 is not part of my solution. It has an open circle. Now, as this is going on here, that means it's going toward positive infinity. So it means that's going to go on forever to positive infinity. Now, the range, though, the range is only at 3. This is a horizontal line, so the range is just 3. It's just 3, forever 3, just 3. Okay, so I wanted to let you guys know that that's just 3. All right, now for this other function over here, it is, let's do domain. I got sidetracked there for a second. So my domain, whoops, I don't want to put a, there you go. If you notice at 2, it's a solid dot. So it's a solid dot right there. So that means it's going to be a bracket. That's going to be 2. And if you notice the x-axis, it's going to keep, if this line keeps on moving, that means it goes forever over here. It could be like negative 1,000 and some number. So this is going to go on forever in the negative x direction. Now my range, though, is a little different. My range starts at 1. And then if you notice, all of the y values are smaller than 1. So it goes toward the negative y infinity. So negative infinity in the y direction. All right, so that would be known as a piecewise function. So now we're going to talk about how to identify pictures, graphs, polygons, whatever. It could be a circle, it could be a square, it could be whatever. If they give you a graph and they ask you, can you identify this function, if it's a function or not? Well, you can. It's known as the vertical line test. If you draw a vertical line through a graph, and if it hits it in 2 places, it is not a function. If it hits it in 1 place, it is a function. Okay? So please read through this. It's really important. I'm going to just show you a picture right here, though. It says use the vertical line test to see whether or not that this is a function. So I'm going to go ahead and go, I draw a straight line, pretend like it's a straight line, and it hits it in 1 place. So this is a function. Like earlier when I saw this problem, I was thinking it was the same thing. All right, so this here is a function because it only hits it in 1 place. Now, sometimes they only want you to tell me what the domain is. And I'm going to go ahead and get started with this one. So first of all, you can do 2 things. You can make yourself a graph if you want to. You can make yourself a table if you want to. On this one, letter A, it looks like it's in slope-intercept form. So I'm just going to go ahead and graph this real quickly. This is your y-intercept. This is your slope, which is negative 2 over 1. So I'm going to go up 7, negative 1, 2, 3, 4, 5, 6, 7, and then 1, 2. So I'm going to quickly graph this because then I can see it a little bit better. I'm going to go up 7, put a point. Then I'm going to go down 2 and over 1. Because my slope is negative 2 over 1, my y-intercept is 7. You always graph the y-intercept and then use the slope to find the second point. Now I'm going to connect these two, and I have myself a graph. Now they only want you to tell me what the domain is. Now the domain for this, really important. On the x-axis, as this line goes on, it goes on forever in the positive x direction. And it goes, as you notice, as this graph goes upward, it goes on forever in the negative x direction. So this is going to be a negative infinity to a positive infinity. It's going to be all of the x values. You can put in any x value you want, and you would get some y value when you're finished. Okay? Now, this bottom one, though, is a little trickier. I can't just put in any number in for x, because remember, I only want the domain. So what you're going to end up doing is, let me just pretend like I'm going to make a little table. Okay? If I put in the number 0 for x, y is going to have to be 0. If I put in the number negative 1, you guys, I would never be able to do anything to y to the 4th power to give me negative 1. So that's not going to work. So I can't have any negative numbers. So just by knowing that, I know that I can start at 0, and then I can plug in any number I want. Any number that is positive, though. So any number to positive infinity. And that would be the domain for that one. And then the next one would be really important is letter D. Whenever you have y equals to a fraction, what you're going to do is I always circle the denominator, And when you circle the denominator, you're left with, you take it and you set it equal to 0. The reason why you set it equal to 0 is to remember you can never have 0 in the denominator. So whatever number this turns out to be, it cannot be part of my solution. So I'm going to go ahead and solve it right now. I'm going to minus the 5 to both sides. I get 3x equals negative 5. I'm going to divide by 3, and x is equal to negative 5/3. So what this means is my domain, I can put any number I want in there, any number, but I cannot put negative 5/3 in it. And I need to pick numbers that are larger than negative 5/3, because if not, it's going to leave me with a very super tiny small number. So I need to pick any number that is larger than negative 5/3, and so I'm going to say to infinity. Okay? And now we're going to talk about a function is a relation in which for each distinct value of the first component of an ordered pairs, there is exactly one value of the second. You guys, basically, if something is a function, x cannot repeat. All right, I don't care about the y value. The y value could repeat as many times as it wants to, but the x value cannot repeat. All righty, so that is it for today. I will get you to the next video. If I can find how to stop this. Have a great day. Bye.